Hello everyone, my name is Ruslan. I am co-founder and CEO of Gelastic Multi-Cloud Platform as a Service. And today I would like to share our experience how we run Kubernetes together with nested containers and how this technology can be used for improving performance, price, and provisioning. Ready? Let's go. During this session, we will talk about business and technical sides. We will analyze Kubernetes popularity and its growing adoption, as well as available offerings on public and private clouds. We will also discuss virtualization and containers types and how we can apply containers for increasing density and efficiency for infrastructure. Also, we will talk about major differences between pay-as-you-go and pay-as-you-use or pay-per-use billing models. And we will compare scaling of virtual machines to containers. And of course, we will talk a little bit about Kubernetes current challenges and available solutions on the market, and what Gelastic provides for end customers to solve the challenges today. So what is the Kubernetes in general? Kubernetes was open sourced by Google in 2014, and it was donated to Cloud Native Foundation. So this great technology now is available for many projects, for large or even small businesses. And a lot of cloud vendors introduced offerings related to Kubernetes in their cloud platforms. So majority of vendors already offer some managed or unmanaged Kubernetes services. Kubernetes popularity is growing. We can analyze this by collecting statistic from, for example, Stack Overflow, how many questions people ask on this popular platform related to Kubernetes. So you can see the graph is growing. Another good indicator how many forks and stars the project has. You can find the latest statistic here. So it means there are many companies already contributing or at least using this technology for their businesses. And Google Trends say the popularity of Kubernetes-related search terms are bigger now compared to the traditional VPS market. It's a good signal for Kubernetes community. Many companies say that Kubernetes is a new everything. Specifically, VMware says Kubernetes is a new Java. And Red Hat says Kubernetes is a new application server, or even it's the new Linux. I can agree with some of the statements. Yes, Kubernetes is so great that it can potentially replace already existing technologies that we call them legacy, let's say. From other side, I don't believe it's solution for everything. So it will replace some technologies, but some of them will stay for a longer time. If we analyze drivers behind Kubernetes adoption, I believe cost of downtimes is one of the major drivers. Because if you have downtime, you lose revenue. You lose trust to your brand from your customers. And in addition, you may lose productivity of your team because team should stop and fix production problem. So people are looking for a solution, and Kubernetes give a promise to solve this issue through availability and advanced scaling and portability across different locations and clouds. If you talk about other drivers behind Kubernetes adoption, scaling is another one. It's much easier now to scale your applications or services with containers because containers are more elastic and more flexible compared to virtual machines. Also, portability is a good feature of Kubernetes. So there is a promise if you write for Kubernetes, and there are so many providers on the market already, you will be able to migrate from one service provider to another one. Unfortunately, it's not 100% true because different cloud vendors offer different distribution of Kubernetes. So they pack and deploy Kubernetes in a different way. It may happen that in some cases you will have to do some adjustments for your application. I hope this problem will be solved in the future and we will get more standardized Kubernetes deployments across different cloud vendors. Also, faster time to market. Containers help to implement advanced continuous integration and continuous delivery pipelines. So you can deliver products faster to your customers. So you can satisfy your customers more often now. Community is one more great driver. There are so big community behind Kubernetes, and there are many smart guys involved into the project. So if you have a question, you will be able to find answer on your question. And if it's not answered yet, you can reach people easily because community is quite friendly. Even it's a little bit competitive, but still people are willing to help when you have a problem. Money and cost saving is another driver because containers can help you to optimize your infrastructure utilization. With containers, you can put more workloads on the same infrastructure compared to virtual machines. Analyzing industries that are adopting Kubernetes, we can notice that the software developing companies have the biggest share, simply because these companies used to try new technologies. So, and the rest industries are often using software which was developed by Z companies. So during the time, we will see bigger adoption across the rest industries. There are great stories on the market about Kubernetes adoption. So big names shared their use cases. It's great to see that Kubernetes works in production at large scale. Analyzing where people run Kubernetes today, we can compare Kubernetes running on-premise and public cloud. And based on Gartner report, we see that during the time, people migrate from on-premise to public cloud or multi-cloud. And there are specific reasons behind this that we will talk about this a little bit later. But in general, there is a great move from on-premise to public cloud. And who are the major player on the public cloud market? As I mentioned already, almost every large cloud vendor introduced Kubernetes-related services already. So it's not hard to find managed Kubernetes or unmanaged Kubernetes at cloud provider in your country. Also, there are major players who offer Kubernetes for installations on-premise or for hybrid or multi-cloud. And yeah, market is quite competitive, but it's good for end customers because there is a great choice of solutions. And yeah, you can consider which one suits better for your needs. So now let's jump to technical side and talk a little bit about virtualization and container types. So I believe everyone knows about application containers. Actually, when people talk about containers, in the most cases, they think about Docker. Why it's like this? Because Docker did a very good job in terms of marketing and promoted application containers across the world, and people got excited about application containers. So again, when people say container, today in the most cases they think about application container, about Docker. However, reality is the following: that there are different kind of containers. There are system containers as well. And they are on the market more than 15 years. Yes, they were available before Docker became popular and available. So these containers are introduced by mostly today on the market by LXC and Virtuoso. They offer this technology for many years already. And the great thing that you can combine application containers together with system containers. So here you can see we have system container engine, and we can run Docker inside our system container, right? And we can run other applications close to our Docker inside the same system container engine. And then we can run applications containers inside our Docker engine. So here we have nested containers. This is how we work in Gelastic. This is how we deliver Kubernetes today. We will talk in details a little bit later. And majority of cloud vendors offer Kubernetes today on top of virtual machine. So where you have hypervisor, guest OS, and you can run Docker engine inside, and then application containers inside this engine. So when you need to use application containers and system containers, if you write microservice application, most likely it's better to use application container. So application containers were designed to run one main service per container. It's not a good idea to put multiple services inside one container. It's better to put them separately and run multiple containers. While system containers were designed to run multiple services inside multiple applications, so in the same way as virtual machines do today. If you want to migrate your legacy application from virtual machines to containers, and you don't want to spend efforts and time right now on redesign and rewrite of your system, but you want to enjoy elasticity of containers and this density of containers, you can consider system containers as a good solution for you. Because yes, it's possible to lift and shift your application and migrate it from virtual machines to system containers. Maybe it will not be a microservice, but still you can get a lot of benefits from density and utilization and elasticity of containers. Now, talking about efficiency of infrastructure, let's analyze two use cases. On the left side, we have Kubernetes, which is running on VM-based host. Right, we have infrastructure here, we have host operating system, hypervisor, then we have two virtual machines, and each of them has guest OS, right? And then we run Kubernetes node inside this virtual machine. This is how it works at majority of cloud vendors today. As you can see, virtual machine has guest OS, and this guest OS definitely has own memory and CPU and disk footprint. So it's not free. It consumes some resources. While on container-based host, we have the same infrastructure, host operating system, then container engine, and then we create system containers, right? And we can put Kubernetes nodes inside the system containers. Yes, there is no guest OS footprint, as you can notice, because actually these containers are running inside the same kernel. So they will share operating system resources from the host operating system. Now, if we think about this approach from a higher point of view, let's say we run large VM-based host machine, and we have many virtual machines inside this host, you can see that each VM has own footprint, and at the end we will lose significant amount of resources because they were not utilized by applications, so they're utilized by guest OS systems. While with containers, this problem does not exist because simply containers are sharing operating system from the host machine, so they are running in the same kernel. And this is more efficient compared to virtual machines. And thinking about this from data center point of view, it's much more efficient to run containers-based infrastructure compared to VM-based. So you can put more workloads inside, you can do more elastic scaling of your applications, and you can improve efficiency of your infrastructure at the end. Analyzing scaling of virtual machines and containers, let's talk about virtual machines first. At this slide, we have our great virtual machine, which has OS footprint, right? Some resources that required to run guest OS. We also have our great application that consume some resources. And as we see, a lot is variable. And we have resource limits for this virtual machine, let's say 18 gigabyte of RAM, right? In the most cases, you will put these limits higher compared to average usage of your application because you want to have some room just in case if more load is coming. So your application will need immediately these additional resources. So again, in the most cases, you reserve more resources than you need in average. And these resources will be wasted because you cannot share these resources with your other virtual machines. Yes, there is a memory ballooning solution for virtual machines, but it's very complicated and it may lead to performance degradation. And also, I did not see that public cloud vendors offer ballooning for customers. So you cannot reallocate unused resources from one virtual machine to another one. Now let's analyze containers. So let's say we have the same 16 gigabyte limits for container, right? The difference compared to virtual machines is that unused resources can be shared with other containers that are running on the same host. So you can set high limits just in case if you need them, but if you don't use them, these resources will be shared across other containers. So you may say like, okay, what happens if all containers will request immediately all resources? In reality, it does not happen. So because you put really big host machine, let's say 256 gigabyte of RAM, and you put small containers inside. So it's very unlikely that all containers will consume everything at the same time. Because in the most cases, you will even keep some free space on your, let's say, pool on your host machine, just in case if one container needs more resources. So now let's think about horizontal scaling. If we have our virtual machine with high limits for just in case if more load is coming to this specific virtual machine, and we scale this horizontally, we scale inefficiency and we scale waste together with our horizontal scaling. It's different with containers because, as I mentioned already, even if you scale horizontally and you don't use resources allocated for your containers, these resources will be shared with other containers on the same host machine. Let's analyze vertical scaling in public cloud. So, for example, we have our small virtual machine like 4 gigabyte of RAM, but at some point we understood we need a little bit more, let's say 5. At the most cloud vendors, you will not be able to get a little bit more into the same virtual machine. You will have to provision twice bigger machine, and it will be new virtual machine. So you will have to do manual migration from old one to a new one. And then, for example, now we have 8 gigabyte, right? And we need like 2 more 10. Again, we cannot get 10. We have to get 16. It can be different with containers. First of all, you can resize scaling limits on the flight without the need to restart the container. And also, you can do it by small pieces. So if you need just 1 more gigabyte, you can easily increase or decrease the limits for this container. So in other words, vertical scaling with containers is easier, cheaper, and faster compared to virtual machines. Now let's talk about pay-per-use and pay-as-you-go. As you know, majority of cloud vendors offer today pay-as-you-go. So what does it mean? You pay only when your virtual machine is running, right? So you don't pay when virtual machine is stopped. However, there is a trick. You will pay for the limits, not for the real usage inside of your virtual machine, right? And as I mentioned already, in the most cases, you will provision more resources than you need in average, because just in case if load coming, your application will need these resources immediately. So again, pay as you go means pay for the limits when your virtual machine is up and running. It's different compared to pay per use. So you can set scaling limit, but if you don't use this all resources, you will pay only for what you consume. It's much more convenient because it solves right sizing problem. You don't need to guess in advance how much memory will be consumed by your services or by your applications. So you can just set high limits and pay only when you consume these resources. What kind of challenges we have today on the market and what are the possible solutions? So First of all, let's analyze the beginning of Kubernetes, right? The world was simple. It was a Linux, it was a Docker, and it was a Kubernetes. Now situation is different. Docker was decomposed into different components, and you can mix and match them depending on what you want to achieve. So it brings more puzzles, it brings more complexity, while it gives some flexibility, of course. But in general, there are too many things to consider, like pod, node, service, ingress controller, namespace, deployment, stateless set, stateful set. So it's not easy for the beginners just wake up and become a Kubernetes expert. You have to spend significant amount of time to learn, to understand how it works and how to troubleshoot Kubernetes. Also, another challenge is upgrading Kubernetes from old version to a new one. It may happen that new version has incompatibility with the previous one, or your application is depending on some modules from the old version. So it can be really challenging. And I will suggest to test this on staging environment before you deploy to production. Non-technical challenges. It may happen that a team becomes excited about Kubernetes and they go for Kubernetes, right? But during the implementation, they faced difficulties. So as a result, outcome is delayed, and management and the team in general becomes frustrated, right? Also, resource challenges. Sometimes it's difficult to find people who has great knowledge and in Kubernetes, right? And people very often are focused on different projects. So it's one of the reasons why many companies prefer to run managed Kubernetes, because they don't need to spend efforts for managing infrastructure, right? And they don't need to hire additional people. Also, budgeting can be additional issue, because actually hiring advanced Kubernetes expert can be expensive, right? So again, like, think about how to optimize your situation. Maybe managed Kubernetes services is the best solution for you. Running Kubernetes can be compared to running like airplane. Yes, there are so many buttons and things you can tune and configure. So if you want to run Kubernetes on premise, you have to have advanced team with required skills to manage the Kubernetes. From other side, in public cloud, you can get a managed Kubernetes experience. So experts will do the dirty job for you, and you can enjoy just deploying Kubernetes inside managed cluster, deploy applications inside managed Kubernetes cluster. Complexity of Kubernetes drives public cloud adoption, because simply you don't want to spend your valuable team resources on learning how to manage and how to troubleshoot Kubernetes. Because in the most cases, if you are not a service provider, I mean cloud service provider or hosting service provider, running Kubernetes is not your core business, right? You want to focus on product development and service development for your customer. So this is the reason why people prefer to get services from managed service providers. Also, running Kubernetes on premise can be inefficient, because in general, private cloud is less efficient compared to public cloud. If you don't have security concerns, it makes sense to consider moving your workloads to a public cloud, because if load spikes is coming, it's much cheaper to buy resources from public cloud for a short period of time and then release it back than order in advance resources and keep them in on premise just in case if load is coming, right? So also need for speed. Again, like, if you don't focus on your resources on managing Kubernetes, you can reallocate these resources to product development and for improving quality of your product, for improving speed of delivery of your product. So that are the reasons that drive shift from on-premise to a public cloud. How to get the required knowledge? There are two ways. You can train your team in-house, hire more people with the required knowledge, or you can work with experts collaborate with experts. Even we do collaboration with outside experts because sometimes it's so complicated that without help from outside, even our team have some struggles. What is Elastic response to Kubernetes challenges and difficulties? We introduced our packaged Kubernetes, and yes, we run this Kubernetes inside system containers. So let me do a short demo for you. We have Elastic dashboard. There are two main elements. Topology wizard, where you can deploy containers, specified topology. I mean, choose different predefined container runtimes, right, for Java, Ruby, PHP, Node.js, Python, Golang, or even custom Docker containers. And also marketplace. Actually, Kubernetes is located in marketplace. You can easily find it here. You press a button, install, and then we provide wizard to choose, okay, is it clean cluster or you need to deploy some Helm via shell command. Also, is it a development environment or let's say production environment? Development environment will have one master node by default and one scalable worker. I mean, you can add extra workers afterward. And production will offer the 3 master nodes with API balancers and scalable workers, 2 by default, and you can add more afterward. There are 3 ingress controllers provided by default: HA proxy, Nginx, and traffic. Also, you can choose dashboard version 1 or version 2 and attach dedicated NFS storage, install Prometheus and Grafana, just check button, and install Jagger tracing tools and enable remote API. And at the end, you can choose region where to deploy. Like again, it's a demo cluster. This demo cluster has like 4 different regions. So I have some pre-deployed clusters already, just to speed up demo. So I have production clusters. Yeah, here like 3 masters, 2 workers, 2 load balancers. And I have some dev cluster where I deployed vertical scaling load test before. So let's analyze how much RAM our workers consume, right? We have statistic panel, and at this statistic panel, you see like red line is the limits, vertical scaling limits. So you can see we have like 30 gigabyte for all workers to scale up. But in reality, we don't use all this RAM. So in reality, we use like 5 times less. It means at the end, your bill will be based only on the green line, on the real used resources. And let's take a look deeper at one of them, and one of the workers, I mean. So you can see like there is a variable load, right? So load goes up and down. Your application is safe because it doesn't reach limit. But just in case if load goes a little bit higher, right, there is still space for scaling up. But at the end, again, like your billing will reflect only this green line, not the red line as at pay per as you go model. Yep. So this is pay per use model. Also, we can get access directly to our master node through WebSSH. Yep, and we can write our kubectl commands. Yeah, for example, you see our cluster up and running. We can see like how much RAM we have. Right, in total we have like 4 gigabyte. Let's increase a little bit more. Let's add a little bit more RAM on the flight. So I want to add like 2 gigabyte more, right? So I just drag and drop and add 2 gigabyte more and apply. So we need to wait several seconds till this applied to our master container. And now let's check how much RAM we have. You see, like now 6. I even did not lose my WebSSH session. So this is in short. Let's talk about multi-cloud and multi-data center locations. So, as we discussed before, Kubernetes promises portability. So, if you write for Kubernetes, there is a big chance that you will be able to migrate without the need to redesign your application from one cloud provider to another one. But for people who want to achieve, let's say, full interoperability to unify deployments across different locations and different cloud vendors, I will suggest to consider some applications, some platforms that deliver your custom Kubernetes distributions. Then you will be able to deploy the same Kubernetes on premise, on public cloud, or on multi-cloud. So Jelastic is one of them. We have independent network of distributed cloud service providers across the globe. It's about more than 70 data centers already. And also Jelastic is available as a private cloud, so it can be installed on top of any infrastructure on premise or on the data center you prefer. And it can be connected to other cloud vendors. As a quick summary, during this presentation, we talk about nested containers and how it can be used together with Kubernetes, right? We discussed differences between pay-as-you-go compared to pay-per-use billing models, and what kind of benefits it can bring for Kubernetes and for optimizing cost of your infrastructure. We also analyzed different challenges that are still present in Kubernetes community and available solution to them. So if you have any questions, please ask me in the chat or send me a message via social media or send in to email specified at this website. Thank you very much and have a great day. Okay, hello, thank you for the question about Prometheus. So the question is, where are deployments of Prometheus? For example, how can we customize it? So again, it depends on service provider, because as I mentioned, different service providers may package in a different way. If you're talking specifically about our company, how we do this, there is a manifest on GitHub. There is a manifest on GitHub where you can customize your default installation, or after installation, you can use, let's say, default setup and then jump inside and customize your specific dashboard, let's say. So it's possible, again, like to customize our default manifest or to use default installation and customize already inside. So this is how it works, for example, at Jelastic. At other cloud providers, it may be a little bit different. But in general, we install on masternode. I hope I answered the question. Okay. Another question. What tool do you use to deploy Kubernetes node on top of system containers? So that's a good question. Actually, it's a combination of tools. First of all, you need to have a great system containers engine. Then double check that Kubernetes works well on top of it. We actually patched one of the container engines, system container engines, for full compatibility with Kubernetes. Some features were absent, let's say, or like it was some conflicts, and we did some polishing before. And after, we have internal tool which is called like cloud scripting, where we write simple manifests and we can subscribe on different events and operate Kubernetes. Actually, we can deploy it through cloud scripting and then react on different actions. For example, when load is growing, and we can trigger automatic horizontal scaling, and then trigger additional post scaling actions and connect new worker node to the cluster. Same, it happens when you scale down or scale in. So when you remove worker node, so you can subscribe or we can subscribe on events before removing the node and do some actions to evacuate, let's say, applications. But in general, to answer your question, we use internal solution. We use our own cloud scripting tool. So there is a documentation. If you write like Elastic Cloud Scripting, you will be able to find what it means and how it works. Okay, there is another question: why system containers are not as popular as application containers? That's a good question. I was thinking about this as well. Mostly because system containers were used by system administrators for a long time. So developers did not have access and actually did not hear about these technologies very much. When Docker came to the stage, they did different approach. So they introduced containers for developers. So they promised developers simplicity. So it's easy to deploy, it's easy to pack, and so on. So it's easy to run on local computer. So this is why I believe Docker became so popular. So they changed this technology, they introduced the containers for developers. And of course, marketing efforts. Docker was awesome in terms of marketing, specifically at the early days. So everyone was excited about this technology. And so this is the reason why, again, like application containers became so popular. And also application containers, it's a good approach for, let's say, next generation of applications when you want to write a microservice or cloud native application. While system containers are good for already existing workloads for legacy applications. As I mentioned, you can use benefits of containers without the need to completely redesign your application and to make it, let's say, as a microservice. It's fine to use containers even like for monoliths. It's not a problem. Like so, and not every application should become a microservice. It's necessary step for a large scale project, let's say, right, to move to cloud native and microservice, because if you have a high load and availability is very important and scaling is very important in your case, you don't want to get downtimes, right? But if your application is working fine already, but you want just enjoy it from containers elasticity, you can migrate easily from virtual machines to system containers. And as you can see, we can also use system containers together with Kubernetes. So it's even improves efficiency at the end. Thank you for the great question. Okay, there are a few more questions. Does the system start scaling horizontally after worker nodes reach a limit of vertical scaling? Yes, you can set specific triggers for horizontal scaling. For example, when CPU usage or RAM usage or like traffic usage is coming to a specific threshold, then we can trigger automatic horizontal scaling and add more workers. Okay, so another question: how do you implement heavy-ability if several Kubernetes nodes live on same machine? Actually, in big scale deployment, for example, when service provider offer cloud hosting platform, they don't have one node, they have many nodes, right? And by default, in our solution, we distribute worker nodes from the same cluster across different physical nodes. For example, let's say hosting service provider cloud cluster contains of let's say 20 big physical nodes, right? When you create a Kubernetes cluster and you request let's say 10 worker nodes, all these 10 worker nodes will be distributed across all these physical machines. So, but where is the efficiency? Efficiency in the big scale. Because service providers, they offer and they serve multiple end customers, like thousands of end customers, right? So we just put worker nodes of different clusters on the same physical node. So again, like just to summarize, worker nodes from the same cluster will be distributed across physical nodes available in cloud hosting cluster, let's say, Elastic cluster. On the same physical node, we can host worker nodes from different customers. Hope it's clear.